Welcome to episode number 49 of this series where we're programming an NES game live on Twitch from scratch in assembly language. Thanks for joining in today, and sorry about last Thursday. Just like I mentioned on the stream last Monday, a lot of stuff going on, so it didn't look like streaming was going to happen on Thursday, but that's okay. Working on Zero Pages episode 2, making some good progress in recovering the project, or reconstructing the project really, from the mishap I had with it. So hopefully that'll be posted tomorrow in the evening sometime, and that'll be on Number Systems. I'm trying to keep those videos down to about 10 minutes, so all the audio is done. I think I need to splice in one more piece there, but maybe not. I'm not sure. We'll see. Yeah, just covering how number systems work and why they're useful for programming. And again, in like about 10 minutes. And then after that, I'll be doing probably an episode on assembly language. And again, in 10 minutes, kind of overview everything that's relevant to know. Which is tough, I mean, because assembly language in and of itself is simple, but putting it together is not so simple. Especially if you don't know what you're doing, but hopefully it'll kind of all come together as we cover the topics here. So, anyway, let's get started. The last time we were working on collision. And specifically, we were working on colliding with elements of the map, the background. So if we open up this bumper metatile and turn on the grid, we can see that we have some collision overlay here, which is why it's slightly more gray. That indicates that I've made that collidable. And so what we had done in the assembly language stuff was we had added some code to check the position of the player, and we had modified the code for the way the player is positioned to map it into essentially world coordinates rather than in just screen coordinates, in order to display everything, or rather, in order to be able to map that to the actual location in the map. Because just kind of recapping this again, what we had before was, if this was one screen, the player's coordinates were purely their location on the screen, and we changed it so that we had the player recording its position relative to this map, so it was a 16-bit value. And then what was happening is we were translating that value into a position on this map to determine if we were flying over a metatile that had any collidable subtiles in it. So if we go into, let's look at that code. It's been a little while. So if we go into this code, what we were doing was we were looking at whether or not, let's see, metatile lookup. Yeah, this is why I didn't want to skip for a whole week, but unfortunately couldn't really do anything about that. So we are looking up the metatile here, and then, oh, okay, so that was, so yeah, so we were looking up the metatile that we were flying over in order to determine if we were even doing the mapping properly, and we left it at that. Let's double check where we're at with that, because I don't remember. there's an update. Well, against my better judgment. Well, it wouldn't let me update, so that's weird, but okay. Let's not worry about that right now. So what I want to do is I want to find this location. And I want to look at the value that we actually get there. And I guess we only want to do that if A is not 0. I forget how the syntax in this works. A equals, is this like C syntax, where you can say A does not equal 0? Would that work? Looks like it. Or maybe not. I don't know. That's weird. Edit breakpoint. It is C++ syntax. So conditional. A value of register. Weird. I thought this was working last time. Let's see. We'll make this y doesn't equal 0. Okay, so that's good because we had just hit that blue band there. So we look up metatile lookup. Why is that not yielding the right results? Metatile lookup. Max metatiles. Oh, wait a minute. Because I think we want to do that. Yep, that's why. Okay, that makes sense. So we were just treating it like it was an array, treating it like it was a pointer into memory when really it was not. It was just a, it's just a lookup into an array of memory, right? So metatile lookup is the actual memory we want to look into, and then we want to offset by y. And we were saying get the address of what's at metatile lookup, and then use that to look into memory and see what's there. So a doesn't equal 0. A is 2. 2. So we should see this as we're flying over question is, I mean, that looks pretty close. But it's odd that it's not doing that for the bumper tiles. So that could mean our X alignment is messed up, which, let's see. Let's slow down the emulation here a little bit. That's not right. So is it in the wrong, looking at the wrong X or the wrong Y position? The Y position looks okay, but the X position is not correct. Let's see here. Yeah, the Y position looks fine, but it looks like it's not offsetting. It looks like it's not offsetting correctly into the map over the background. Right now, all we're testing for is, are we on something that isn't a background black tile? And so just moving to the left a little bit, it's pushing us over into, it looks like this. So let's take a look at what's going on here with our exposition situation. Temp is X. So it takes the X position, which is our normal position on the map, and then it's dividing that to find the offset into the map. So 2, 4, 6, 8, 16. No, 30, it's doing 32. It's 5 shifts, right? So we're dividing that X position by 32. Right, because if we have our position on the screen within 240, so let's say it's at 120 and we divide it by 32, then, well, it thinks it's over here. Am I being dense right now? Like if the player is flying over here, right, it's going to map them over to, oh yeah, 0, 1, 2, 3, right? It's going to say it's over this. So then if it goes, let's see, 120, so 119 divided by 32 is also here. Let's just make sure that that's actually calculating or got the right, has the expected value. Yeah, that's the value that I would expect. Let's make sure we're looking at this here. 7E. $126. So it's even higher than I thought it was, but that's fine. That math is correct. So temp has that 3. And then we're doing our division of the Y position, which is 16 bits. So add a param F7. Really? Am I storing this in the wrong order? No, that's right. Because, let's see. It's BF7 divided by 32 3D. Load A, it's F6. Adder param. Load A. So BF6, right? BF6 divided by 30. Oh, not by 32, by 20. 5F. Okay. I was mixing decimal and hex, so I got the wrong answer. So it should be 5F, which is what we were getting in adder param. Yep, 5F, which is 95. So it's not even 95. So that would be 95, 0, 1, 2, 3. So we should be, something is off, it looks like. What? Right, so let's see, so we're now calculating 95, 5F, 5F times 8. So we should get 2F8. And then we're adding 3 to that. And we're getting 2FB. Branch carry clear. Adder param 1. 2FB, that's correct. So the only other thing I can think of is that level mem is actually pointing to the wrong address, maybe? EC3F. Let's look at the memory. EC3F. That looks correct to me. You know what we can do? We can test this by, or make sure that it's good by putting a tile here. So if we see a value at the point it's pointing to, then we know that we've calculated that right. If it's 0 still, then we know we've messed that up. Okay, let's replace that. And go back to the asset tool. And let's just export that. And really the only thing I need to copy over is level 1 because nothing else changed. Alright, so let's rebuild that and reset messen and go into the debugger. And so what we should do now, because the math looks good. Okay, so we hit our breakpoint when we hit here, but I know that if we shift over to the left one, we were getting the wrong thing. So let's look at level mem. Level mem says EC3F. Memory, go to EC3F. Okay, so that's wrong. It's actually off by 1, which would make sense because it was saying that the collidable tile was here instead of here. Okay. The question is, why are we off by 1 for level mem? Store a row mem, and then store a level mem plus 1, load a, clear carry, add, I'm adding 9. So we have the row count, that's 1 byte, right? And then we have 4 pallets, so that's 5 total bytes. Then we have the pallet loop, that's 8 total bytes. Oh. Wait, no. 1 byte for the row count. Did we change that to 2 bytes? No. So we have 1 byte for the row count. We have 4 for the map metatiles. For the pallets, we have 4 plus 1. Why did I do that? Map look. Oh, because 0, right. Because we're forcing that 0. So that's why. So we have to add 10. That's why we're off by 1. I should probably put together something to describe that format so I don't keep forgetting these things. Real quick, let's jot that down. Oh, really? Hold on. Oh, now it activated? Okay. Sorry about that. So, map binary format. Header. Map row count, 1 byte. Map pallets, 4 times 4 byte pallets. Map metatile lookup table, 4 times 5 times 1 byte. This is wrong too. This is 4 by 1 byte pallets. Pallet index value. 5 metatile. Metatiles are normalized, and this converts between map normalized metatile and metatile lookup buffer. Map data equals 8 times n rows bytes. Right. Eight times n rows bytes. Okay. Just so I don't have to keep looking this up. All right, so we run that. We can move to the left, no problem. We don't collide anymore. We hit the blue stripe and bam. All right, so now once we get out of there, let's see, we can move to the collide with that. Okay, we're colliding with that now. So what I want to do is I want to just watch this in memory while we're looking at this. And I think I had created a variable to do that. Player collided with a byte. So let's do that. Jump entity. Didn't know you could change the size of the text here. The only thing is it looks like it doesn't refresh when until you scroll. Anyway, okay, so the game is running there. Metatile, no, player collided. Yep. So let's get rid of that, and that is at address 90. So let's go to memory and go to 90, and now we just watch that address and see it change as we move. Okay, that looks pretty good. I want to kind of put it next to it and see how. Okay, that's looking good. That looks like what you'd expect. All right, cool. So now we have that. So now we want to, there is the collision data, which we stored off. Empty collision. So now, let's see, load A, empty collision. I don't know if you can you do that without a problem? I feel like there's a reason I did that, but I don't remember. Let's see what that looks like first before. Okay, that makes sense. I kind of thought you couldn't use a load Y with the Y offset like that. All right, so we're going to load that, and then we're going to store that. Oh, yeah. I didn't change that one. Okay. Empty. Huh? Okay. So now we should see a 1 when we fly over the bumper. Except that we're not. Let's see why that is. Empty collision is the problem. What is the problem? Or we wouldn't see a 1, we would see a value that's not 0. So we are writing the collision data. Are we offsetting that by... Yeah, we are. Oh, it's got to be multiplied by 2 because it's 2 bytes for collision. I forgot about that. And then, All right, let's see here. Really, Well, let's start by multiplying by 2 and then see if we get something. Okay, so there was a value there. So that's working correctly now. Insofar as we're getting the first byte of the collision data. Let's see. So it's not triggering unless we fly over those bumpers, which is what we want. So that's cool. So now I guess we can start with, let's make the player's sprite, let's make the player entity die. So let's see, does the player have any sort of special? It doesn't. We have the type, so we could store that in the data. I want that to be a scope called player entity state alive equals 0, dying, the dying, I never remember, dead, and that'll be our transition. Can even add another byte in here called timer for any sort of entity specific timing. Any specific timing, for example, dying animation timer. And then what we'll do, let's see. Process player load A entities plus entity data X compare player entity state alive branch not equal to branch equal to I'm sure we're going to have to do this anyway, so jump to where is it? Entity complete, and then we have that label there. So we're checking to see is the player alive, and if it's not, then we're going to jump to entity complete. Otherwise, we'll go through this whole process again. And then, let's see. What we want to do is if the player collided state is, if A is not 0 here, branch if equal to there, and we'll jump to entity complete. Otherwise, load A, player entity state dead, store A, entities plus entity data X. So the player will now hopefully disappear if we bonk into that thing, and it did not. What did I mess up? It seemed like that should have been straightforward and should have worked. Load A. Okay. Branch load A empty collision Y, branch if equal to there, load A player blah, blah, store A entities plus entity data X. That seems correct. Entities entity data X, compare alive branch equal to that, otherwise jump to entity complete. Make sure it really got built. Reload. I am confused, and I shouldn't have closed that. Load A empty collision Y. That shouldn't need to happen, but okay, let's try that. Let's just make sure. Okay, what am I doing wrong here? Oh, should that be like that? I think so. I think so. I think I messed that up. I think that's all it was. Okay, now you can't process it anymore. And then I guess what we should do, okay, so that actually worked, and then the next part is the draw entities should be checking how to draw the player sprite properly. Now this is interesting because we really haven't talked about how we do these kinds of transitions and how this all kind of works, but let's start with this. Let's just get it so that it outputs code for drawing the entities that acknowledges the player's state properly. Although we really don't have any way of telling it that, so it's kind of generically drawing the sprite. So we're going to have to add some ability to add some some additional information to the level to be able to handle this. For now, let me just add this code manually to here, and then we can talk about how we're going to add that to the level. So we're going to load that. We're going to compare it against what did I call it? Player entity state dead branch not equal to next one, otherwise jump to check end sprite, and then here's the label. No such scope. No, there certainly isn't. Okay. So now it should stop drawing the sprite when we collide, and it did. Cool. So, and then eventually we would want the scrolling to stop and the level to reset and start over again. But so that's really coarsely checking the collision. So the question is now, are we dropping? I wonder if there's a way to know if we're dropping frames because we're taking too long. It's a game loop. I don't want to do this. I just want to see how that correlates. Let's see. So we are definitely part of it is because we are waiting for NMI to finish before we process the frame. So that's actually okay. I wonder how we can have to look and see if there's a good way to I'm trying to sorry that I'm kind of like stumbling over this. I'm trying to think of what's the best way for us to detect if the game is taking longer than a frame to process the logic, because we don't want to do that, and that would mean we would want to. I can't tell if the little bit of sort of juddering that I see when I'm looking at this here is because of it being on an emulator with OBS running, or if it's actually happening. This, running it slowly like this, it seems to be just running at a constant rate. And then we collide, and so that's every time we hit the top of the game loop. You know, let's jump game loop. That's at the end here. Let's make that marked. So we should be able to see the two pieces here. guess that still doesn't tell us. It doesn't tell us if we're going over frame. I mean, it looks like it's going at a pretty consistent speed, so I'm not overly worried. You know, we can always tweak that later. It's certainly not unplayable or anything. It's claiming it's, you know, running at 60 frames or 61 frames, but I feel like that's probably the emulator's speed, not, you know, it clocking how quickly the game is running. I don't know how we would know that for sure. I mean, other than we could put in some so if I let's do this. So increment x compare to 255, branch not equal, back one. Let's just add a bogus loop here, and we should probably compare x to that and not a. What's the problem? Colon expected, branch not equal. 1506. Oh, CPX. Oops. So if we add in a garbage loop into this and purposely slow this down, let's see what happens. It still seems to run reasonably well. Yes, I'm disappointed. I'm disappointed that it's running well. I was hoping to see a slowdown. Should we do a couple of them? The whole point of this is I want to see how the emulator behaves if we do that. Let's just add in a bunch of CPU spin weights. So that's interesting. It seems to have no effect on that is load x 0, increment x, compare x, branch if not equal. I mean, it's got to be doing it, right? Repeat 50 and rep. Or is this process? Collision. The other thing is we can speed things up by not using JSR. It's actually slow to do that, but we don't need to worry about that right now. And that only affects the game when you have those entities out in the game. Okay, now it's running way more slow. So what does that look like? If we open the event viewer, we open the debugger, get rid of that one's okay. That is not okay. What is the code? It's just jump game loop. It's this one. And, you know, I probably shouldn't do it from here because the problem is wow, it's just, you know, that repeat that CC65 generates, it just doesn't like it. Seems to create confusion about what's actually happening. Which, I mean, I get because it's kind of it's specific to CC65, and I doubt that there's any emitted data to let Mesin know that that's what it's doing. Here, let's do this instead of wasting time trying to figure out why Mesin doesn't like it. So we're just putting two loops together essentially to achieve the same effect. This way I don't have to worry about the unroll. So this is going to run super duper slow. Okay, so let's pause that for a second and jump game loop. Viewer. So I wanted to see if there's any sort of discernible way of knowing that you're missing frames. I mean, you can see that they're happening. It's kind of hard to, well, you know what, that's probably it, is that you're not seeing consistent marked breakpoints for every frame. Because I guess it's redrawing faster than it's actually getting, well, no, it's locking it in place. So, well, you know what? I wasted too much time on this already. Sorry. I was just curious to know how it was running, and ultimately, I guess it's fine that we don't know for sure right now anyway. So we'll spend too much time trying to optimize it. The game isn't even anywhere near done. I guess what we're looking for is to make sure that we see those dots for every frame. I don't know. I'll have to ask around and do some research because I don't know. But we did manage to get it so that the player ship, if it collides with something that's collidable, it breaks. Now or it doesn't break. The ship is destroyed. So now what I want to do is I want to make this a little bit more fine-grained, and we know we can do that because we had set this up so that in the grid you can draw which of these tiles within this are collidable. And so when we were loading the collision data, the first byte we were loading is the low byte of the collision. Essentially, I believe, if I'm remembering how we did this, it's these first 8 tiles packed into one byte. And we can confirm that by opening the file and looking at the collision data. This is the wrong one. Yeah, so okay, it's the reverse order. What does it look like in which folder do I want? Hey Vashtarek. So we want this line, and what I want to do is I want to edit breakpoint on this where a doesn't equal 0. And this only works because we have collision data that spans the 2 bytes. If this part of this, if half of it wasn't collidable, then this wouldn't work because we're not looking at the 2 bytes. But luckily we are. So let's run and hit start. And now we've collided. And so we've got 7, 0, and if we look in this, that's the first byte. So it's actually in reverse order, right? Because this is 7, 0, and then 0, 7. I believe that's in reverse order. Let's save the metatile and reload this. Oh, this is in the shooter folder. Hold on. Seven one. 7-1. So does that mean? Seven. I forget exactly what order we did. So when I turn that one on, seven. So let's see, 1, 2, 3, 4. Right. So if I turn these two on and I reload it, we should get what 15 and 15 0 0 15 or F 0 0 F, right? So the order 01 means that this least significant bit is the top left. Why am I storing it that way? I don't know that I really gave it that much thought in the way that I was storing the ordering of the collision. So let's see. So if this is the top left, you'd get 0, 0. So 0, 0 was turned on. So what did I shift this by? By 4. So it's shifted 0 places, which makes it 1. Which makes sense. So this is the least significant bit, and then that means this is the most significant bit. Right? Because 8, 0 gives us the most. Okay. So it's sort of backwards a little bit, but let's see if that works out okay. So let's see. So when we were originally calculating this, what we were doing was we were normalizing this to the map position to determine where on the metatile grid it fell by dividing by 32. So what we did was we said we found the position on this map, right? So if we're flying here, we found that it's at 493, right, which is where we are. We're at 493. And then now we want to see where is it in relation to being within that metatile. So what we need to do is now do we difference the positions, and then we difference the coordinates of the metatile and then divide by 8 to find the position in that grid. I mean, that would work. And we have, let's see, so temp has the X value. Before we load, sorry, I'm just kind of thinking this through because we've gotten this far and it's relatively straightforward. Now it gets a little more tricky because now we have to, relative to this metatile, find where we land on that. And I'm trying to think of if there's a way to do that without additional fussing over the math, or if that's still going to require us taking the difference of the positions and then recalculating within that grid. What we could do, let's see, we could change the way we're doing it a little bit. If we say, if we divide by 8 to find out where we are on the 8 grid position, right, that gives us the individual tile location that we're at, but then we need to also know the metatile to look up the metatile before we then determine if we are. It's so much easier when you can use larger numeric values easily. I mean, I guess this is fine. The exposition only requires 1 byte. It's the Y position that's... It's the Y position that I was thinking about that I'm not crazy about storing off. This is for random... We don't really need this anymore. Right? We're not using that, so... That was for... I was doing a flickering effect on the... on part of the sprite, but it was using the randomness to determine if it should do it or not, and it doesn't really need to do that. We don't need to do that. So what I want to do is I want to call this temp word. Move this here. Do we use flicker anywhere? No, so we can get rid of that. Do we need collision temp anywhere? We are using that. Okay. All right, so we calculated our Y here, and then we were adding X to it immediately. So what I want to do is I want to store the Y value so that we have access to it if in case the collision did occur. So A has part of the value, and so store A in temp word, and then store load Y adder param 1 plus 1, store Y in temp word plus 1. Okay, so let's just make sure that I did that right. We'll just look at the values here to make sure. So temp word. Why are you not adder param? Why is it not showing that? Let's reload this here for a second. There we go. Okay, so 300 and adder param had 360. Load Y adder param temp word. Oh, because A... Okay, that's actually right, I think, because 304, yeah, 300. Okay, good, that's right. So temp word has 300, which is the value that Y is after being divided by 32, right? 3,200. So if it's like 3,200, let's do it in decimal. It's 64. That's 100. Why does that seem wrong? Probably because it is, but why in particular? Oh, because I've already... Okay. Because I forgot, we are... This is where we are multiplying by multiply by 8 to find offset into map. Temp is X. Okay, that's why. So it was because we had the we had already found the value, but we were then multiplying by 8 to find the offset into the map. So load A. No. Store a temp word +1, and then load Y, adder param, and then store Y into temp word. I think that'll get what we want now. Put it over here, and then reload. So A is 0, and adder param is 60. 60 temp word is now 60, which is correct because, I mean, that was based on 3200, which was the maximum row position. So that's correct. So now we have that Y value. And that Y value is the value that the actually right, okay, no, that's fine. So that's the value of the tile Y. We have the tile X at temp. That's going to be correct, right? Because we're not overwriting that. And so then what we need to do is, if there's a collision, we now want to take the player's position and subtract that from temp and temp word to see if to then figure out where in the smaller 8x8 grid the player falls. So let's see. So subtract the player XY from the tile world XY to find out player offset on metatile. Use that difference to divide by 8 to find the subtile offset and determine if the tile is collidable. Yeah, it's collidable. So now, what a pain. This is so much easier to do in C. But at the same time, we can see how many different operations happen here by doing this. Just trying to think if there's any way to get that value without having to kind of go back and forth and back and forth. But off the top of my head, I'm sure I'll think about this, and then by Thursday I'll have come up with something where it was like, oh, that was dumb. But right now, off the top of my head, I can't think of anything obvious. Like if the player's position, let's play around with this for a little bit here. If the player's position, it was 3200 minus 120, right? Because it was halfway up the screen already. We have C08, so it's C08. Let's see what So if we divide that by 32, we get 96 or 60 in hex. I'm just looking for correlations here to see if there's anything obvious that we're missing. About how to do this transformation. So let's see. I mean, when you're dividing it by 32, right? Effectively, you're shifting the bits. So why? Oh, okay, because this is a 16. So right, so we're shifting it 5 times. So you can see this 4-bit value gets shifted into this 4-bit value here in this location. So this whole set of 4 bits is meaningless, really. When we do that, so I wonder. Wonder if there's anything we can do. I mean, because the problem is we do that division by 32, we get 96 because it's not using floating point, and we then do the multiplication, we get essentially the nearest value, which is 3072. So it's dropped. That 1 bit here that was set is gone because it got shifted off, which is what we want when we do the division. That part is fine. And then what we're saying is we take the 3080 and we subtract 3072. 3080 minus 3072, no, that's in hex. 3080 minus 3072 in decimal gives us 8. And then obviously we divide that by 8 and we get 1. And that would give us a position relative to that metatile. So we're in row 1 of 4, or it's row 2. It's row with an offset of 1, right? Because there's row 0, there's row 1, row 2, and row 3. So we're in the second row of the metatile. I wonder if there's a way to figure that out without all these gyrations. Like basically say, we know we fall on some given metatile. We don't really care which one it is. We just want to know for that value which row it would be based on our. I feel like we should be able to do that, right? Because let's look at the range of values for a metatile. If we only had one metatile, I don't know why the stylus keeps doing that. If we only had one metatile, right? Our values for y could be 0 through 31. Which is in hex, that's 0 through 1f. And then those values essentially map to a range of 0 through 8. 7, for the for what we're trying to do. So if we did 31 divided by 7 and it gives divide by 4. So if we do 28 divided by 4, we get 7. And then 27 by 4, we get 6. So what do we, if we take the value from over the metatile, let's see, I guess that does make sense, right? Because we say it's 30, if we get to 32, if we divide by 4, that's 8, but we've gone beyond the range that we want to allow for, and so we truncate it. So let's see if that works. So if we have a value of 3080 and divide by 4, and then we end it with 7, we get the value of 2. If we go through all of these crazy mathematical calculations that we do, 3080 divided by 32 gets us row number 96, right? So we're in row number 96, and then what we say is, okay, so if we then find out where row 96 begins, it's 3072. So 3080 minus 3072 gets us a value of 8 as the difference, and then we divide that by 8 and get 1. So it's saying, yeah, and well, see, if we're at 3072 here and the ship is at 3080, 73, 74, 75, 76, 77, 78, 79, 80. That is row 1. So why doesn't this extrapolate the way I want it to? If we do this for now a second metatile that we have here, the values are 32 through 63, which is 20 through 2 F, is that right? No, 3F. And again, the values that we are looking for are 0 through 7. So if we take 63 and divide by 4, and then perform an AND of 7, that works there. If we're at 32 and divide by 4, and we AND 7, we get 0. Did I just do, let's see, 3080 divided by 4 and 7 gets us 2. Am I just wrong? Is 3072 divided by 32? 32 divided by 32 is 1. So for 3072 divided by 4 and 7 gets us 0. Okay. So that seems right. 3071 divided by 4 and 7. 30. Is it 73 divided by 4 and 7. 0 still. So let's see, 3079 divided by 4 and 7 gets us 1. Where does the transition begin? 76 divided by 4 and 7. Well, that's not right, because if 3072 is the first part of that, then let's see. Okay, so is it divide by 4? So if we're dividing by 4, we're finding where .8081 divided by 32. Okay, because that's mapping to the individual metatile. So 3080 divided by 8 tells us that it's tile number 385. And then if we were to divide that by 4 and 7, no, 3080 by 8 and 7. Yeah. So dividing by 8 and then doing an AND of 7 would work because... Okay, so maybe that's what we do. Instead of these crazy... Because basically what we're doing is then we're saying, look, we know that we're now falling... Because this is all a grid, we know that we're falling within a metatile... We're falling within a metatile that maps to a 32 by 32. Right? So let's find out where on that 32 by 32 grid we fall. Let's say it's over here. Then we say, okay, is that collidable? And it is. So then we go, okay, if it's collidable, I need to know where we are inside that. So then for the y coordinate, we just take the ship's y coordinate, 3080, and divide it by 8 to find out which tile it's within. And then we do an AND of 7 because it's a power of 2 that we're trying to essentially modulo this to, right? Where we want to clamp it down to a value that's possible, a possible value of 0 to 7. And we're saying, okay, what is it? 1. And that makes sense, right? Because if the metatile starts at 3072, which is what we saw, then row 0 in that goes up to 3080. And then if we go to 3088, that's row 2. So if we said, okay, we're at 3088, divide by 8, and then mod 7. Yeah. Okay, so that does actually work. That's kind of cool because now we don't have to do these crazy subtractions and all this other stuff because, yeah, that works. Okay, so take the player Y value, world value, and now divide by 8 to find the position on the 8x8 grid, clamping or mod 8, mod 7, so that we get a value of 0 through 7, which is the row in the metatile that we are potentially colliding with. Right? Because this is a potential collision. These are sub collision points. So it's possible that we get here and we look and we say, oh, actually, we don't collide with anything. So there's nothing we need to do now, and the player isn't dead. All right, so let's take the player's Y position again. And we're dividing by 8, so 2, 4, 8. So we only need these 3 shifts. So that's kind of nice that we get to just take that code we wrote already. That gives us our Y position. For the X position, again, it's much simpler because we're not scrolling left and right, so we just divide that by 8 to find out what its position is. And then we offset that into the metatile collision data. So once we have that, we then want to shift back left. And we want to do that what, by 4, right? Yes, we want to do that by 4. We only need to do adder param 1 because we know that the value we're going to get has to be within 0 to 7. So the upper value in A doesn't even matter anymore. It was only important for when we were doing the divide. So now we're doing an AND on that, and then we are shifting that. So we know that the value of 7 times 4 will fit within a single byte, right? That's only 28. And again, we're doing that because... Wait, do we want to do by 4? Yeah. Yeah. Oh, wait a minute. Why was I saying 0 through 7? It should be 0 through 4. I think this still applies, though. Please, hopefully. We still want to divide by 8. So 3080 divided by 8 and 3 still gets us 1. Yeah, and then let's just check. So if we do 32 divided by 8 and 3, we get 0, and then 32 plus, so 40 divided by 8 and 3 gets us 1. Okay, yes, that still works. I just confused my math, my sizes a little bit, but it's still a power of 2, and it's still a simple division. We're still dividing by 8. It's just that we want to clamp this to 4. I just, in thinking about this, confused myself because the row is 4. And that's why I was saying, well, how could 7 times 4 fit into this? It can't. It's 0 through 4. So again, 3 times 4 we know will fit within a byte easily. So there's no problem there. And then we want to load a X world position, or is it just X position X? And then for this same deal, we want to shift right twice, 3 times, 2, 4, 8. So that's our divide by 8, and then clear the carry and add carry, add adder param 1, And that gives us our offset into the metatile collision data. And then we said the collision data is stored such that this is hex 70. It is least significant bit first. Is that what I said? I've already forgotten. Seven one. No, it's least significant bit. Yeah, least significant bit first. So what we want to do is now we want to check the bit that this value correlates to. So for example, in this case, if x is let's see, if we know we're at 3080 and we divide by our 8 and then we mod by 4, we get our 1. So then that's times 4, and then let's say the exposition is like right smack in the middle of the screen. So that's 240 by that's 120 divided by 8 mod 3. No, we don't have to do that. We just divide by. Oh yeah, we do need to do that. Mod 3 is 0. So if we do, let's do 128 divided by 8 mod 3. Yep. Okay. So this is the least significant bit, and we want to check, let's say, bit number. We want to check tile at this was 1, right? 3080 divided by 8 mod 3. It's 1. So we want to check at 1 1, right? Which is over here. The bits, that's the 1 2 3 4 5. Yeah, that's bit offset number 5 in the byte. So first we have to check, is the value greater than 8? Because if it is, we want the second byte. And then after that, we want to shift the value by the, let's see, do we want to shift it by the number in the result of the add? I guess we do, right? Because 1 2 3 4 5, that would shift the bit to the least significant bit. The other possibility, yeah, no, that's fine. And then we mask it so that that's the only bit that's set, if it's set. And then we check if it's 0. And if it's not 0, then we've collided. Did you get all that? All right, so exposition divided by 8 and modded mod 4 0 through 8 0 through 3 mod 4. Okay, so exposition divided by 8 and mod 4 to find out final bit position. We want to look at did not change y here, which is good because we need it. So we say, okay, clear carry, add carry. So that gives us our final bit location. Compare adder param, no, compare a to 8. And this is where I forget again what 6502, how we do this comparison nonsense with the greater than, less than comparisons. It's greater than or equal to, which is, let's see, if the value is 8, then is that 0, 1, 2, 3, 4, 5, 6, 7. Yeah, so if it's greater than or equal to, so if the carry is 1, then A is, okay. So we want a branch carry set. Compare branch carry set, no, branch carry clear, because if it's less than 8, we're good with the collision value that we have loaded. So we're going to go to the next label, which is here. Otherwise, the carry was set, which meant it's greater than or equal to 8. And what we want to do is we want to load a empty collisions plus 1, load a empty collisions plus 1 y. I think we can do that. Yeah. And then we don't need this label. Well, we will need this label. All right, so then except I don't want it there. We can store that in temp now, so that's fine. Load a in there. That's good because that's our bit pattern. And then what we want to do is we want to shift based on the value that is in temp now. And actually, what we need to do is two things. We need to A has a value in it. We want to set clear and then subtract 8 from it, because we need to account for the fact that we are loading a new byte, which has the second set of bits for the collision in it. And then we load the actual collision data. And now we're in a position where, let's see, then we want to store that in temp. And now we can load y with temp because we don't care about that. And we will shift it until it's 0. I guess what we want to do first is compare y to 0. If it's already 0, then branch if equal to this, which is here. So if it's not equal to 0, then right, if it's 0, we don't have to do any shifts. All right, so then yes, LSR. So that's one shift. decrement y, branch, and just jump back. Oops. We'll call this collide bit shift. We'll label this one just in case, collide bit shift. So then we want to compare and see if it's 0. Again, so if it was 1, we shifted 1, and then we compare it after we okay, that looks correct. So now that we're here, now we're going to AND the value with 1 because we only care about the least significant bit. And we're going to compare it to 0 and branch if not equal to branch if equal to that. 1472. Oh yeah, that doesn't work. All right, who knows if this is going to be right? I think it's going to be close, but we will see. Let's take a look here. So I want to go to collide bit shift. Okay, so that exposition is right. This is the okay. So we're here. I don't care about that. We shouldn't be here unless we get a collision with something. So that's good. So let's see what that looks like. Okay, so we hit a metatile where we can possibly collide. So we get the position of the ship, and it is at BF, and then we're doing our shift where we're going to divide by 8. So in hex BBF, oh, I don't want it to be byte only. It can be a word, that's fine. BBF is 3007. So if we divide that by 8, come on, calculator, help me out here. BBF divided by 8 gets us 177 in hex, and then we're AND up by 3, that gets us 3. So what we should see is that A should have the value of 3, and then we're going to multiply that by 4. Oh, crap. We didn't store that AND here. Okay, I gotta do the same thing here. Actually, I don't have to do that there. Oops, okay. Adder param. Okay, so we shouldn't get a collision here because we haven't hit one of the tiles that actually has a collision mask on it. So we do this and we store that. So adder param 1 has the value of 3, and then we shift it twice, and that gives us 12. And then we take the x value, which is 80 in hex, and then we do some shifts on it, and we get the value of 16, and then we AND that and we get 0, and that looks right. I mean, that's like right there, the 0, and it's in that last row. So that all looks correct. So now we're going to add adder param to that, so we get C, which means we're right here, and that shouldn't be collidable. So let's store that into temp. And then we're going to compare it to 8, and we should do the branch logic here because it should be flagging it as greater than or equal to 8. It is, so we're going to subtract 8 from that. We're going to get 4. And then we're going to store that in temp because that's how many times we have to shift it. And then we want to load A with empty collision +1 for Y. And that value is 7. And that's right. So that's good. And then we're going to load Y with the value of temp, which is how many times we want to do shift. So we're going to compare against 0. It's not equal, so we're going to shift 1 time. So 7, 7, if we shift it 3 times, or 4 times, it should say we're not going to get a collision, which is right. That's actually what it's supposed to do. So what I want to see is if we get to a point now where after doing the shift we properly hit the collision and where that falls. And there it is. And that's right, because if we look at our mask, it's not until we hit this tile that we actually collide. And so if we turn off the breakpoint, the player ship should disappear. Now, more importantly is if we restart the game and run it, I gotta find the right position. I can't see where the sprite begins exactly. Yeah, you see how it didn't collide there? That's exactly what we want. Obviously that collision testing is a little bit wonky because it's not 100% right. The wing is not being tested. It's really that corner. You know what? I can actually rewind. I forgot about that. It's just the top corner of the ship. That's what's testing for collision. So as long as that part isn't hitting the metatile, you can see it's colliding with the metatile but not disappearing. It'd be cool if we could have some sort of visual reference there for the corner. You know what we could do? I could modify here. You know what we'll do? We'll modify the sprite to have. I'll just do it in the hex editor. We'll modify the sprite to have the top left corner have some visible pixels so we can see where that collision should be occurring. Now the real trick is if I'm going to remember how to do this. Oh, whoa. No, Fred. Stop. So I want to make that 1, I think. And then rebuild this. And then restart this. Oh, wait a minute. Okay, because that's the character ROM for the entire game, not for the ship. Where is the player character? All right, so that was just, I forgot that I didn't call the ship shooter. It's just a, let's take a look at the PPU here. So, okay, so we've got, and that's because just the way that the bits are mapped, I think that needs to be 8. Let's rebuild and reload, and let's take a look at that again. Yeah, okay, cool. So now the sprite top corner pixel is turned on. We can see where that falls so that we don't have to worry about guessing if we're going to collide. That looks correct to me. I mean, it's not something we would use in the game, obviously, but the basis is there, right? So now we have the top corner colliding accurately with what we have in the definition for the metatile. Trying to really get it down to the pixel perfect miss. You can see that I'm skimming over it with the top left corner there, but if we look at the map of the collisions, it's just that gray part right on the edge that's not collidable. Yes, that was it. Did you see that? Oops. It's really hard to get that movement like exactly right. I think that's it. Yep. You see that? So the pixel is right here. It's not colliding because it's skimming. It's right on the edge of the tiles that are collidable. So the challenge is going to be, of course, that we need to set up our metatiles in such a way that we take advantage of the appropriate mapping that we have. But this is the basis. Now, the other thing is that we don't want to be checking the collision of the player's world position based on the corner here. We want to do it based on some key points. We want to do it at the nose of the ship and the front of the two wings. So that's going to be for next time, I think, how we do this. What's also interesting is it seems like I can't... let's see, is it possible to get it to do that if I fly into it sideways? Yeah, it did work sideways. It's just moving at a clip that it's kind of hard to do, and once that point is passed, it doesn't collide anymore. So so this is it. This is how the world collision is going to work. Now we're basically going to spend we're basically going to set it up so that we have assets that take advantage of the way that we have these sub collisions. We're going to also have to change the ship to allow for multiple collision points that we check. And then the other thing that we don't handle properly still is the motion up and down, because of the changes we made for accommodating the world position. We also probably want to work in a death animation, or at least a death transition, where it doesn't go immediately to dead, it goes to dying, and then after dying it will switch to dead after a certain count occurs, which could potentially mess with the sprite, so that the player sprite is no longer the ship, but instead an explosion. But we have to, in the asset tool, be able to essentially track that, right? So right now the asset tool doesn't understand anything about the sprite other than, I have multiple instances open, other than the fact that it is a sprite, right? And it has this generic collision bounding box around it. We also have to be able to say, okay, there are going to be states that are associated with this sprite, where they should be looked for, what other sprites will have to be used for the animation. So we've got a little bit of stuff that we need to add to the asset tool to handle that. It's not super critical for what we're working on right now, ultimately, because that's kind of all polished stuff. I mean, obviously we want to do it because it makes the game look better and look more finished. But right now, what I want to do is I want to work on getting the world collision to be more precise with the ship. Probably want to have something where we can define those collision checkpoints rather than just a bounding box. Well, the bounding box would be for bullets, so we still need that. But we need to be able to define, okay, these are the positions, like we want to put a position over here and here and here, and those are what we're checking against the metatile information. So looking at this right now, for the player, we're doing this calculation one time to find the metatile, and then within that we're doing another calculation if we determine that the metatile is a collidable metatile. What we actually want to do also so what I'm doing here is because there are 2 bytes that define the collision information. Actually, it doesn't even have to be an add, it can be just an or. All I want to do is I want to make sure that we're looking at the value of both bytes and making sure that they're not 0, right? Because if either one of them has a bit set, then there is collision in the metatile, which means that we now need to go down further and do this additional check for the sub metatile collision. Okay. So I think I'm going to wrap it up here. Made some good progress. Obviously still more to go, but that's to be expected. So Stream 50 is the next one. I had posted on Twitter and on the YouTube channel to see if anybody had any special requests for Stream 50. I'm going to think about it. That's coming up Thursday at 9 p.m. Eastern. Maybe we'll do something special. Maybe we'll do something for the 100th stream. I don't know. That'll come up quicker than we think. The other thing is approaching 300 subscribers on YouTube, which is pretty cool because honestly, if you had told me that 300 people would have subscribed for this channel about NES programming and watching that live or recordings of it, I don't know that I would have believed you, but it's pretty exciting to know that so many people are interested in NES programming and are getting something out of this. So like I said, Zero Pages episode number 2 will be hopefully posted tomorrow, probably sometime in the evening. And as always, if you have any questions, I'm on Twitter at Clearvis. You can always also post questions and comments on the recording, which is posted on YouTube. And come to Nintendo Age, talk to the people there. There are a few people that I've seen from the streams join on Nintendo Age and join in on the chat and Discord, which is awesome. Great to see more people. And hopefully this was... I felt like we made some really good progress, and other than my usual sort of confusion situation, I think we're doing well, and hopefully people found this interesting, and I'll see you next time. So thanks for watching.